So this is the first question where we'll be discussing the CodeChef latest round. So we're given that there are two defined two permutations A and B, each of length n, and we can define the distance as the minimum value between AI minus BI mode for all I 1 to n. We have to find a pair of permutations which have the maximum possible distance. All right. So n will be up to 100 and t is only up to 100. So we just have to print the two permutations which have the maximum distance. Distance we can define the minimum value of this mode of AI minus BI for all I. And we want to maximize the distance. Let's think of this. Let's think of like some simple case first. Let's think of n is equals to 6. 1, 2, 3, 4, 5, 6. Like whenever we see a question in which we have to make a permutation, like two permutations, we'll try to fill it in the opposite order and see what is the answer, right? So we'll try here also. 6, 5, 4, 3, 2, 1. In this case, the answer is 1 because the difference is always 1, right? So this is all right. So is the answer, can the answer be something better? That is the question. And yes, we can make it better. Let's think how. Let's think how. Uh, First permutation, I'll obviously choose 1, 2, 3, 4, 5, 6. Like, you can always choose this most of the times. And the second permutation, we need to think something that will give us the answer more than 1. So we need the difference between each index to be at max, like more than 1. We wanted more than 1. So we can get an answer of 2 maybe, or maybe answer of 3. So let's think of a pairing. If I pair 1 with 4, if I pair 2 with 5, and 3 with 6, then what will happen? If you think of this, then the difference between 1 and 4 will be 3, 2 and 5 will be 3, and 3 and 6 will also be 3. So that way we can do this. Let's say 1 I've paired with 4, okay, 1 I've paired with 4, 2 I've paired with 5, 3 I've paired with 6, means 1 I've paired with 4, so 4, 1, 5, 2, and 3. So the difference is 3, 3, 3, 3, 3, and 3. So the answer is 3. So is it the best? Yes, it is. And why we can think of it like this, that we can always get an answer of n by 2 seal at max. You cannot, sorry, not seal, floor. You can get an answer of n by 2 floor at max. Why? Let's try to get answer something more than that. Like if we want to this, in this case, we'll get the answer 3. If I try to make answer more than this, I need something with 1 which gives a difference of 4. Let's say we are trying to make an answer of 4 now. So 1 I'm going to try and pair with 5 because that is going to give a difference of 4. 2 I can pair with 6, but 3 I cannot pair with anyone because 3 will always be paired with 4 in this case because there is no two elements left, and that will decrease the minimum difference. That will make it 1. The answer will be 1 in this case if we try to do it like this. So what is happening here? You can at max make an answer of n by 2 floor because you can find pairings like this with n by 2. But if you try to do with more than n by 2, you cannot make the pairings. Some guy will be left and which will make the difference lower, and we need to take the minimum of all the distances, right? So this will be the answer in this case. So, and similarly in the odd case, if you think about this, let's say n is equals to 5, 1, 2, 3, 4, 5. Let's say now, like the best possible answer is in this way, obviously, like n by 2. This you can make like this, right? But if you think the other way around, if you uh like if you want to try and increase the answer is 2, 2, 2, 2. This is 3, this is 3. So the maximum possible difference and the minimum of all this is 2. The answer here is 2, which is equal to n by 2 seed for law. It is always the n by 2 floor. You can make the answer at max, right? You cannot increase it more here because if you try to pair 1 with something else, let's say you try to pair 1 with 4, then you try to pair 2 with 5 to make the answer 3. then you cannot pair 3 with anyone. You cannot pair 3 with anyone now because you need someone whose difference is 3. We're trying to give the answer from n by 2 floor, right? So we need a difference 3 with, but there is no element which has a difference 3 which we can put below 3 to like uh in, keep the distance, keep the ai minus bi mod 3. So that is not possible. So the maximum possible answer is n by 2 floor, and you can always make it this way, the way I told, like I was telling earlier. First permutation will take 1 to n, right? Then the second permutation will start from n by 2 plus 1. Like we are always starting from n by 2 plus 1. In the case for 1, n is equals to 6, 1, 2, 3, 4, 5, 6. I'll pair 1 with n by 2 plus 1. Always I'm saying n by 2 plus 1. So n by 2 plus 1 to n first you will print, then you will go for 1 to n by 2. And that should do it. Thanks for the first question. So this is the second question of the contest. So a given define fx be the largest divisor of x other than x itself. For example, fk is equal to 6, fn is equal to 1. Given an integer k, we need to find the sum of all n such that fn is equal to k. Right? So k is equal to 10 power 6 and d is equal to 10 power 4. Well, let's think of this. For any number, let's say 2, 3, they have given the first example, so you consider this only. For t, the only possible number is 4. For 3, the only possible number is the two possible numbers are 6 and 9. Why? 4 has, like, if you think of its divisors, the largest divisor except itself is 2. And for 6 and 9, both, the largest divisor except themselves is 3. So the answer here will be 15, the sum of all these numbers, and the answer here will be 4 because the sum of all the numbers which has fn is equals to 2. Right. So and the third case is given 18. So now we can get a note from 18. Let's focus on 18 now. Uh, the only possible number with 18 is actually 36, which is a 2 times multiple of 18, and 2 is the smallest prime divisor of 18. I'm trying to tell you how I got the intuition, and I'm gonna prove it why it works and what I'm going to do. Let's consider any number. Let's consider number 15 firstly. Like from here also will come. The answer is 36 here because it's the only number. Why not any other number? Firstly, let me prove that we'll always multiply k. The number, whichever n is, it has a divisor of k, right? So we can break it into k times something like j. Now I'm going to prove that j can never be composite. If let's say j is composite, so j can be written as a into b. If j is composite, if j can be written as k into b. Let's say n is equals to k into a into b. So if you think about this, then n has a prime divisor k into a, which is bigger than k. So this number will never come in the sum because n has a prime divisor k into a, or if you consider k into b, which is a divisor which is greater than k. So j can never be composite firstly. If you take j composite, that is not going to be possible. So j is not going to be composite first case. So j is always a prime number. Like j prime always. Now which primes? Let's think of this. Let's consider this. There are two cases. That the minimum prime in this number, like the minimum prime factor is 3. Minimum prime factor here is 2. For any number, we'll consider the minimum prime factor firstly. Let's say I take some prime number which is greater than 3, the minimum prime factor of the number. If I take something which is greater than 3, let's consider 15 times 5. Let's say 5 is also there. 15 times 5 if you consider 15 times 5. Can is this a number? Is this a possible number for 15? No, because we can take out the 5 from here and we can put it in there. So we can do 3 into 25. So 25 is a divisor of n, which is bigger than k. So this number is not possible. And it will always be not possible in such a way if we take a prime divisor greater than the smallest prime divisor of the number y. Now let's prove this simply. Uh, we can take the number n is equals to k into some j, which is prime, right? If this prime is greater than the smallest prime factor of this number, then we can leave the smallest prime factor of this number, and let's say that prime factor is let's say a1, smallest prime factor. So a1 we can leave here, and this number j into k by a1 will be here. Now this number is always greater than k. This number is always greater than k. Why? Because this k had the prime factor a1, the minimum prime factor. J is a prime factor which is greater than that. We are removing the prime factor a1, which was smaller, and we are multiplying by a number which is bigger than that. Because we are saying j is a prime factor which is bigger. So this number will always be greater than k. If this number is greater than k, then it is a prime. It is a divisor of the number n greater than k. So this number will not come in the answer. But let's say a1, this j is exactly equal to a1. Then this number is also okay. So then it works. Then it works. So for all, and let's say this number is lesser than uh, a1, then also it works because then this number will be smaller than k. But this largest divisor will remain k because you can write this number as k into a. So looking at this, we can think of the solution quite simply. Get the smallest prime divisor of the number. All the primes which are lesser than that will also work, and we need to take the sum of all of them and multiply it with 18. So multiply it with the number k into all the prime divisors which are lesser than or equal to it. K into sum of all the prime divisors which are lesser than or equal to it. You can write it as this because the numbers will be this one. K into let's say 2, k into 3, 4. This will all come out like this, right? So you can do it like this up to k prime. This is not prime. This is 5. Sorry. 2, 3, 5 on all the primes. We'll only multiply with the prime. The number will be k into j always in such a way that j is a prime which is lesser than or equal to k. So this is a solution, and we can implement this simply. Uh, I've used the sieve just to mark all the numbers between 1 to 10 power 6 is prime or not. You can do it in your own implementations. Now we'll come to the board. So, firstly, I've just marked all the numbers between 1 to 10 power 6 as primes or not. Then I'm making like a prefix sum of all the prime numbers. In answer, I'm keeping the prefix sum of all the prime numbers. Firstly, I'll put 3. Then I'll put answer dot back plus if it's a prime number. I'll firstly use the sieve function to mark all the numbers prime or not. And I'm also keeping an ls. Ls is just a list of the prime numbers. List of all the prime numbers 2, 3, 5, and all sorted. And this is the prefix sum of all the prime numbers that I'm maintaining, taking in the input, and I'm going to check the minimum prime divisor of the number. If the number is prime itself, then it's the number is itself obviously, and then otherwise we can check the minimum prime divisor in order of under root k. You can you know this already. I think you should know this. So I into I should be less than or equal to k. This gives a time complexity order of under root of k, which is possible in the question. 10 power 7 it will be at max. Then after that, I'm finding all the prime numbers which are lesser than or equal to it by using a lower bound function in the prime number list that we have. And the same index I'm taking in the answer, which is a prefix sum into I'm doing k. The same thing I was telling you. Like let's say the minimum prime divisor is 5 of a number. So we need that number into 5 plus that number into 3 plus that number into 2. All the prime numbers which are lesser than equal to the smallest prime number. So we can take out n common from here. This is just the prefix sum of all the prime numbers. And that into the number itself, that is the answer. That is our answer. Right? So yeah, that's it. Thank you for listening. This is the third question. We'll be discussing where an island's number from 1 to n. Every pair is connected initially. Ith island has an importance of I, AI, and the cost of destroying the bridge is AI into AJ. Dominator has powers C, and we want to destroy the edges, the edges of bridges in such a way that the first island is disconnected from as many islands as possible. That is the question. The crux of the question is this: that we want to disconnect the first island with all the other islands. We want to make sure that it is connected with the minimum number of islands. Right. So let's think of it in this way. Uh, so we're given A1, A2, A3 doing wait. A1, A2, A3. Let's take a simple case up to A6, A4, A1. So let's consider this case. We want to make sure that we want to disconnect A1 from as many people as possible, as many nodes as possible. So one way to do it is remove all the edges from A1. Like obviously we can think of this. You remove all the edges from A1, then A1 is an isolated node. Like it is a single node, and it will be disconnected from everyone. What is this case? This case is that we can remove A1 and AJ, all nodes. J can start from 2 to n, and this value is less than equal to 0. This is first case. If we can just make sure that we can isolate node A1, then answer will be best possible. The answer will be 1 because we have isolated the first node. That is one case. You can just isolate the first node and that is the best answer. Right. Or you can think of the other case. Let's say this is greater than C. Then I cannot disconnect it from everyone. So now let's think of the other way. Like now I cannot disconnect it from everyone. So I have to think of something. Now let's say we can try and disconnect people one by one, right? We can try and disconnect A5. If I want to disconnect A5, what will be the cost? So obviously greedily we'll try to remove firstly the guy who has the least cost, right? We will try to remove a guy who has the least cost of removing him, like disconnecting him from the icon. How can you think of that? Let's say A5 is a guy who costs the least first of all. Um, what will be the cost of A5? Removing any element, what will be its cost? The cost will be initially the first time. First element we are removing, the cost will be total sum of the array minus that A. Let's say we are removing A5. So A5 into A5. Why? We'll be removing all the edges A5 into AJ, J equal to 1 to 1, J not equal to 1. J not equal to, sorry, J not equal to 5 here. Sorry, J not equal to 5. We'll try to remove all such edges. So A5 we can take out, and this is just the sum minus A5 because J is not equal to 5 here. So this is the cost of the first island that we're going to need. Right? Total minus A5 into A5. If you want to remove the fifth island, this will be the cost. Now, let's say this is when can we minimize this? When is this cost minimum possible? When A5 is minimum, right? If A5 is something big, then these two values will come closer. If two values come closer, their multiplication becomes higher. Uh, let's say total sum is the total sum of these two is always total, right? A5 plus if we sum both of the number, it will be total. So we want to make sure that their multiplication is minimum. If let's say total we take 4, then if we divide it into two equal parts, it will be 4 into 4, that will be 16. So number should be as far away as possible. Like they should not be close. If the two numbers are close and their sum is fixed, then the multiplication is largest. So this will be minimum. This cost will be minimum in the case when these two numbers are far from each other. That will we can take like A5 should be minimum as possible, right? Take that. A5 should be minimum as possible. That will give us the least cost, right? So we firstly figured out the first island we'll do. Let's think of what will happen when we try to remove the second island. Let's say we can remove this island and this cost is less than equal to C. We removed it now. We want to remove it, then C will decrease this value from C, and C will become C dash, right? C will become C dash. And we have removed A5 from the graph, like from the, we have disconnected it from A1. How can we disconnect? By removing all its edges from everyone else, with everyone. Because if we, let's say, if I only remove with A1, that in A1 and A5, A5 is still connected with A1 using A2, A3, A4, and A6 because they are connected with A1. You can come from A1 to A2, then we can go from A2 to A5. So now I've removed all the edges of A5. So that this is the cost, right? Now let's consider this after we've removed this particular line. Let's consider now I'm trying to remove A3. This gives the minimum cost. Let's think. Okay, now I have to remove this guy. What will be its cost? To remove this guy also. So C will become C dash. Now we can use only C dash amount of coins. Let's say. And how will we remove A3? We'll remove A3 by considering all its edges j equal to 1 to n A3 into AJ, but j cannot be equal to 3 and j cannot be also equal to 5. Why? Because 5, A3 and A5 edge we have already removed. If we've already removed that, then why we need to remove that edge again? So we will not remove that edge again. So j not equal to 3 and j not equal to 5. So A3 we can take out and A3. And this sum is total minus A3 and A5. A3 and A5 you can say A3 minus A5 you can say the deleted part. The node which are already deleted, like disconnected, or you can say disconnected, whatever you use, disconnected, deleted or disconnected. So this is the when we remove the ith node, this is the cost. But if I try to remove A3, this is the cost. Initially, we have not deleted anyone, so we can take it as 0. This in this case, this is A5. So this is A5, yes, because we initially removed A5, right? So this is the cost to remove the second island after removing the first island. This is a general cost. But now let's think of something else. We have to think of one more. This is already. But if I can, if I'm removing A3 and A5, if I'm disconnecting A3 and A5 from A, then is there a point of removing the edge between 3 and 5? We are wasting the money here, right? We are removing the edge between A3 and A5, even though we have disconnected A3 and A5. They can like go around inside each other. Like A3 and A5 can go. Someone at A3 can go to A5. There is no issue in that because they still cannot reach A1 because both of them are disconnected to A1. So what I'm trying to say here is that all the nodes that are disconnected from A1, the edges between them, I don't actually have to remove. You should not remove those edges because they are decreasing, like decreasing our money, and there is no point in decreasing our money. Like you should not remove this A3 and A5 edge. Okay. So what will we do? Every time after doing C dash, I'll decrease this value by the amount or by the cost. Then I'll again update this value to something else. Let's say it became firstly C dash. Then I'll update it with all the people that I've removed. Now whatever guy I'm going to remove, let's say I'm going to remove A3 guy. So whatever guy I'm going to remove now, I'll consider the edge between A3, let's say AI, whichever guy I'm going to remove now, AI, into the edges which are already the nodes which are already deleted. I've deleted A5 already. So the edges, these edges should again be added back to the C dash because these edges I'm not going to use. So AI into deleted. AI into you can say this part you can say all the nodes which are already deleted or disconnected with everyone's. So this goes like what I'm trying to say. That's trying to say more clearly. We can look at it in the other perspective also. I think in Portal, but still I'm going to explain a bit further. Let's say, in the final answer, we have removed A3, we have removed A5, we have removed A6, A4. This is the final answer that we can only remove 3 people. Let's say this is the final answer. So, is there a point in removing the edge between 3 and 4? Is there a point of removing the edge between A3 and A5 and A4 and A5? No, because these edges, if we move these bridges, there is we have no benefit. A3, A4, and A5 are already disconnected from A1. That is what we want. So, okay, so I think this is quite clear. He every time will try to remove an node which seeds post. Will subtract from the post uh, whatever the current post is. AI into AJ, AI into AJ. Is here remove trying to remove uh, the guy AI, and J does not belong to, it does not belong to the deleted set. The people we have already been deleted. It does not belong to that set. I'll subtract it. Then when I'm coming to the next layer, when I'm trying to come to the next layer, where I'm trying to remove the next particular, let's say island, what I'll do, I'll increase the post by this island's A2 into all the people I've already deleted, because these are not useful to remove. There is no point in removing these edges. It's just decreasing your money. We do not want to reduce our money for nothing, right? So we'll add this back to C dash. C dash, you can add this again back. This will be our new C dash, our new, like how much money we have. So this is the overall idea. This is the code. So the code is like this. So this is just the input, and I'm taking the sum, and I'm seeing that if I can disconnect the first guy from everyone else, then just output one. That is this case that I told like initially. This is the first case. The other case is, let's say the answer is n currently, and we have to remove. Now we'll start removing people, and deleted is the set of people that I've removed. I've initially removed no one, so I've kept it 0. And I just show you that we should remove the guy with the minimum value, because they are into AJ we want to make sure that it is minimum display, right? So I've maintained a multiset from 1 to n, because we are not removing the first guy, we cannot remove the first guy ever. Then until it's not empty and C is greater than or equal to 0, I'm taking the first element, which is a minimum element always. Then I'm removing it from the set, and then I'm adding all the guys I've previously deleted into our current money that have shown that these edges need not to be removed. There is no point in removing these edges, right? So we can add them back to our money. Let's say our money too, and then we'll consider like can we make this disconnect this island? How what is the what is the particular formula for that? Total sum minus whatever island we are on, and remove all the previous islands that we have already removed. Into top should be less than equal to C. Then I'll remove this command from C, and I'll add this guy to our disconnected islands. And then you can push it back in the set of disconnected islands. This is our set of disconnected islands. And you can decrease the answer. So initially the answer is n. We will keep on decreasing as much as possible when you output answer. Thank you for watching. That's the solution. If you have any doubts, you can ask me problems. I'll be clearing all of it.
So coming to problem D, we have sort permutation. So we call a permutation P of length n as k-sortable if it is possible to sort the permutation in non-decreasing order using the following operation at least once. Okay, so what is the operation? We have to choose a subset of indices from 1 to n and add k to the elements present at all those indices in P. Okay, and after that we have to tell if we have to calculate the sum of all k. Okay, yeah, we have to print sum of all k such that P is k sortable and k belongs to 1 to n obviously. So we have to find all possible k such that if we choose a subset of indices from 1 to n and at all those indices we add a number k, then that permutation becomes sortable as a whole. Okay, so I have written down these sample test cases uh, and let's see what we can do. So first we have the first test case here. uh, let's see how we can change this permutation to an increasing permutation. So first of all, what do we observe? That if we decrease, if a number has a decreasing sequence, like we have 3 and 1, so this is decreasing, and then we have 4 and 2, 5 and 4, so these are decreasing. So if we increase these numbers, right, we do not need to increase these numbers. If we increase these numbers, the numbers that are in a decreasing sequence, then we can obtain an increasing permutation. Okay, so here we have 3 1 5 4 2, which means we have to increase 1 4 and 2, right? Okay, but the catch here is we have to increase all these indices at once to make it increasing, right? We cannot choose any one of these indices or any two of these indices and change them to make the permutation increasing. We have to change all these indices, right? So what do we do here? Okay, so let's see what number we have to increase. 1. So we can see that we have to increase 1 by 2 to get 3, right? At least the number should be 2. For getting from 4 to 5, we have to increase 4 by at least 1. Okay, and for increasing 2 to 4, we have to increase 2 by at least 2, right? Since we have to increase all these elements, right, and all of them have to be increased by the same number, right? 1k is constant and we have to increase all of these indices by k. Okay, so what k should we choose, right? Now tell me one thing. If I choose 1, if I choose k equals to 1 and increase all these indices by 1, can I make the permutation increasing? So let's try it out. We have 3 2 5 5 and 3. We increase all these indices by 1, right? Is this an increasing permutation? Obviously no. Why? Because here we still need one more, and here we still need like 2 more. So the thing is, we have to choose the maximum of these, the maximum of all the differences between ai and ai minus 1, where ai is less than ai minus 1, right? We have to take the maximum of these indices. Now let us say we increase all the numbers by 2. Then can we make the permutation increasing? So if we increase by 2, we have 3 3, fine, this works. Then we have 5, okay, this is increasing. Then we have again 5, we have 6 here, we increased by 2, this is also increasing. But after that 4, we have 4, right? So we can see that this is decreasing. Why did this happen? We increased all these by 2. So why did this not become an increasing permutation? Here there is another catch that we need to take into consideration. I will tell you that. Let me just rub this. Okay, so the catch is we have 3 1 5 4 2. We are saying we need to increase this number by 2, assuming this number remains constant, right? At the first place, we only assumed that this number will remain constant. Then we said we need to increase this by at least 2, right? But what if we increase this number 2? If we increase this number, then we can never make this equals to this, right? Because we are increasing both these numbers by the same number k, right? So if we increase both these numbers by k, then it is certainly impossible to reach from 2 to 4, right? You all agree to this? What I mean to say, we come to another conclusion, that we cannot choose indices in our subset. We cannot choose indices in our subset that are consecutive and ai is less than ai minus 1. Right, we cannot choose 4 and 2 both in our subset, right? Because if we increase both by k, then we can never reach from 2 to 4. Obviously we can never reach from 2 to 4, so we can never take such indices I such that both are ai and ai minus 1 if ai is less than ai minus 1. You all agree to this? Okay, so one part is complete. Now let us come to another example, the second test case which we had, 2 1 3 4 6 5, right? So we have 2 1 3 4 6 and 5, right? Let us see how we can make this increasing. So we have 2 and 1, this is decreasing, so this needs to be increased by at least 1. We have 3 and 4, this is increasing, this is increasing, this is increasing, and again this is decreasing, so we need to increase this by at least 1. Okay, Now we can definitely say that if we increase both by 1, if we increase both by 1, then it will become increasing. There's no problem in this because no two consecutive elements have been chosen, right? Okay, now what other numbers can we choose? Okay, can we choose 2 here? Can we choose 2 here? Let us check it out. If we increase by 2, we have 2, 3, and this will remain 3. Sorry, this will remain 3, and this will remain 4, this will remain 6, and this will become 7. So we can choose 2, right? Now can we choose 3? So we have 2, 4, then this becomes 3, right? This is a problem, right? This is a problem because then this becomes decreasing. Just a second. Yeah, okay. So this becomes a problem because this becomes 4 and this still remains 3. So we need to increase this one too, right? So if we increase this one, we'll choose the same index, we'll choose the same number, obviously k. So we have 4, 3, we'll increase this also by 3, which means now this will become 6, and after 6 we have 4, right? So we'll need to increase 4 also. If we increase 4 by 3, we have 7, and we'll need to increase 6 also because 7 is greater than 6. So 6 becomes 9, and then obviously 5 becomes 8, right? So this is not possible. This is not possible. You can see why. If we choose 3, we have 2, 4, 6, 7, 9, 8. So up to here it is increasing, but here it becomes decreasing. So this one is not possible. Okay. So if we cannot choose 3, can we choose 4? Can we choose 4? Obviously not, right? Because if we cannot choose 3, we cannot choose a number greater than 3. You understand? If we choose a number 3 and if we also choose a number 4, let's see. We have 2, then we have 3 plus 4, 7. Again we have the same story. Because after 7, we have 4, right? So again 4 we will have to increase by 4 and it will become 8. Then 6 also we will have to increase by, just a second. Okay, why is this occurring? Just a second. Sorry for the disturbance, the internet suddenly crashed. So we were discussing that we had done 1, we had done 2, and then we cannot do numbers greater than 3, right? Greater than or equals to 3, because it was causing an error. What error it was causing? That we realized that we cannot choose both consecutive indices such that ai is less than ai minus 1. Both of them cannot be in the subset, right? But if we choose a number 3 or greater, then we have to increase this, we have to increase this, we have to increase this again, and this is ai minus 1, I minus 1. We cannot choose this index, right? So it is impossible. So can we draw a general pattern from this? Okay, even if it is not a permutation, this is a general pattern we can observe. So I'll tell you what we can observe. You can pause the video and think about it yourself a little. What you can think about this is that if you choose, first of all, we choose the smallest numbers, the numbers such that ai is less than ai minus 1. We choose these indices, right? And we want to increase them, right? So we can see that we can always increase them in a range, right? From here it is 1 to 2. We can always increase them in a range. We cannot increase more than a limit, and we cannot increase less than a limit, right? And this less limit we know how to decide, that we decided in the last example. For example, we have 3 1 5 4 2. So we can have 3 1 5 4 2. So what is the minimum value that we have to increase? So here we can see it is decreasing, here it is decreasing, and here it is decreasing. Here the difference is 2, here the difference is 1, and here the difference is also 2. So at minimum we have to increase by 2, right? So what is the starting value, the minimum value? So the minimum value here is equals to minimum of all differences this is I minus 1 minus ai, right? Such that such that ai minus 1 is greater than ai. Right, we'll take the minimum of all those differences. This is the minimum value we must, oh sorry, this is the maximum, right? We took the maximum here. So this minimum value, this is the starting value that we must increase all of the indices by, is of the maximum value of all these differences such that ai minus 1 is greater than ai. That we decided. Now how do we decide the upper limit? How do we decide the upper limit that we can choose? Okay, so let us think in the same example 4 2. Can we increase by 2? Because the minimum limit is 2, right? So let's see, we have 3 3 5 6 and then 4. Then again there is one problem, is that both these indices are coming, right? And we cannot choose both these indices in our subset. Why we cannot choose? Like we discussed earlier, we cannot choose because in these indices this condition is being satisfied, ai minus 1 is greater than ai, so we cannot choose both of these. Okay, so we'll take advantage of this condition to find the upper bound, right? We'll take advantage of this particular condition that both these indices cannot be taken to find the upper bound. Okay, all right, so let me think of an example where we can discuss this. Forget about permutation for a moment, we'll just take a regular example. So we have here 2 1 3 5 7, then we have 4, and then again let's say we have 5 6, and here we have 1. Okay, all right, so what number can we choose, right? 1 3 5 7 4 5. Okay, so here we have a decreasing number, right? Here we have a decreasing, then we have up to here it is increasing, and there here also we have a decreasing number, right? Okay, so here we have to increase by 1, here the difference is 3, and here the difference is 5. So the lower bound here is 5. We have to increase all these by at least 5. Okay, and what is the upper bound? So the condition is we cannot take both ai and ai minus 1. If we take that, it's a problem, right? So what condition will cause us to take both ai and ai minus 1? Can you think about it? What number what number do we choose? What k do we choose such that if we take this particular k, then ai and I minus 1 both will be selected? This is what we have to find out. Okay, so if you want to think about it, you can pause and think about it yourself. What can be the upper bound? Okay, so because I'm going to reveal the answer right now, so let's try to look at the process reverse wise. Okay, let us see when will we be choosing 7. Okay, we'll be choosing 7 when 5 will be greater than 7, and we'll be choosing 5 if 3 will be greater than 5, and we'll be choosing 3 if 1 will be greater than 3. This means that if we add 3 to 1, it will become 4, right? Let me just clear it once. Okay, so if you want to include 3, we'll be adding 3 to 1, then we have 2, we have 1 plus 3 is 4, and then we have, since we increased 1, we'll have to increase 3 also right now. So 3 plus 3 will be 6, and 5 plus 3 will be 8, and 7 plus 3 will be 10. Okay, just let me write it properly. 8, and then we have 10, and then we have 4. Even if we increase this by 3, this does not matter because this index has already been selected. Okay, so we can think about it in reverse manner. Okay, we can think about it in a reverse manner, that when will this be selected? This will be selected when this will be selected, and this will be selected when this will be selected, and finally this will be selected when this will be selected. Okay, so whatever happens, this propagation should not be carried till the last element. Okay, If this element is selected, then everything is over. Similarly, we can take this segment. We can take this segment from this 4 to this one. Okay, since we have to increase this and this, we'll take the segment in between which is increasing, and we'll calculate for this segment also. When will this segment, when will this 6 be chosen? This 6 will be chosen if this 5 will be chosen. If this 5, when will this 5 will be chosen? This will be when this 4 will be greater than 5. So if we add 2 to 4, then we have 6, and then we will add 2 to 5 also because it's greater than 6, greater than 5, because 6 is greater than 5, and then we'll have 7, and then we'll add 2 here also. This will make it 8, and then this will become 3. Does not matter because this has already been selected. This is invalid. Okay, so take a look at another example. After this I will write a statement and you will have to think about it whether it is correct or not. Okay, so we have, let us try to find the lower bound of this array. This is actual permutation 3, 1, 2, 5, 4, 7 and 6. So we'll first find the lower bound. What minimum number should we, what minimum k can we take, right? So can you tell me the lower bound? So the lower bound here would be the maximum of these 3, that is 2, right? This will be the lower bound, right? And what will be the upper bound? Now we need to calculate the upper bound. Okay, to calculate the upper bound, we'll look at these indices, right? The increasing part. So in the increasing part, we must not be including 5, and we must not be including 7, right? Because if that's included, we cannot convert this array. Okay, so when will 5 be included? 5 will be included when 2 will be greater than 5. This means at max 2 can go up to 5, or we can say that we can take k equals to 3, right? And similarly here for 6, 7 must not be included. This means that 4 cannot be greater than 7. Again this says that k is equals to 3 works, but k greater than 3 will not work, right? So guys, can I say that k equals to 3 is a valid k? Let us check again if k is equals to 3 is valid. So for here we'll not increase this, we'll let it be. So 1 will increase by 3, this will become 4, and since it's greater than 2, we'll also increase 2 by 3, this will now become 5. And remember, 5 will not be included because 2 is not greater than 5, so 5 will be as it is. Then we have 4 plus 3, 7. Then again 7 we will not increase because 4 is less than or equals to 7, like 4 plus 3 is less than or equals to 7, so 7 comes here like this, and 6 plus 3 is 9. We can see that this is a non-decreasing array, and k is a valid k, and 3 is a valid k. So guys, let me make a statement here, and you'll have to figure out why this works. Okay, I'll make this statement, right? So we have upper bound is the minimum value of differences between two consecutive elements where ai is greater than equals to ai minus 1. This will be our upper bound. Okay, try to think why this works, and I've also explained it before. So if you'll take the observations very carefully, you will understand why this works. We are taking each increasing part, and one by one we are considering the differences between the consecutive elements. right? We are considering the differences between consecutive elements, and that difference, and we'll take the minimum of that difference, and because that's the minimum possible k we can take, like maximum possible k we can take. So our k will range from sorry for the bad handwriting, k will range from lower bound to upper bound, right? That's how we'll calculate, and I told you already what lower bound will be and what upper bound will be. So let me just quickly take you through the code. uh, okay, so here's the code here. uh, I have taken the input, then the vector p, the permutation in here, and then we have initialized two values, L, R, and current. Okay, so this L will be the lower bound and R will be the upper bound, which I have initialized by n, because we are taking the minimum each time, so n can be the maximum possible value. That's why I've initialized it by n. And then there's one flag. Okay, I'll tell you the purpose of flag here. So we'll go through the loop, right? And if pi is less than pi minus 1, which means it is a decreasing sequence at that point, then L will be equals to max of L and pi minus 1 minus pi, the difference between those two. This will be L, right? Each time we'll be taking the maximum possible value of L, because like I told you, we'll take the maximum out of these values. Just explain it once again. We have 3, we have this is decreasing, 3, 1, 2, 5, 4, 7, and 3. This is decreasing, and this is 6. So, okay, this is decreasing, so the difference is 2, difference is 1, difference is 1. So this will be the maximum possible value. That's why we are taking the maximum of all L, right? And then see, if flag r equals to min of r comma current, so each time when we go through each interval, like when we go from here to here, when we go from here to here, when we go from here to here, each time we are taking the minimum possible value of the differences, right, between these. Then again minimum possible difference between these, and we'll take the minimum of all these. That's why we are taking if flag r equals to minimum of r comma current, where current is the minimum possible r we've obtained so far, minimum possible difference between the consecutive elements, where ai is greater than ai minus 1. So why this flag? Because if we come initially, right, we have 3, 1, 2 dot, sorry, we have 3, 1, 2 dot dot dot. So we are coming from here and we find the first decreasing element, right? We find the first decreasing element. So note that this number, the numbers before it, can increase up to any value. It does not matter. Like we are increasing it by 3, right? And we will not touch these values. We do not need to even touch these values, because we are just starting from here. This value will not be affected, because these values can be increased as much as they want, and this will not be affected. So for the initial decreasing element 3, 1, 2, this is the first decreasing element. For the first decreasing element, we will not take the r equals to minimum of current comma r. That's why after first value I've initialized flag equals to 1. Initially flag was 0, so initially r will not be minimum of r comma current. From next time onwards, r will be minimum of r comma current, and then we make current equals to 0, because we have to take the maximum of these subsegments, right? So we'll initialize current equals to 0 again, so that we can keep taking the maximum. And else, if pi is greater than equals to pi minus 1, then just current equals to maximum of current comma difference between these two. That's how we can do it. And then there's finally this variable sum. From each L to R we can add just the sum. See, the constraints were pretty light here. You can see that k varies and n varies from 1 to 5v5. That's why I'm just adding up these values through iteration. But it's very easy to just calculate this sum value using r into r plus 1 minus l into l minus 1 l plus 1. But I've just not done it because you can say I'm lazy. So this is the solution. Thank you.